Two people had questions about number 2 from the worksheet for homework today, and so I'm just going to do the whole thing. So here is the equation, and the first thing you have to find is the vertex. So remember, in this problem, A is -2, B is 16, and C is -33, if that helps you to write it. So vertex is -b over 2a. So that's going to be -16 over 2 times -2, which is -16 over -4, which is 4. So my vertex, that's the x value, it's 4 comma something. How do you find the something? Remember, you put that x in for x in the equation. So that's what I'm going to do now. So what you see me writing right now is me just putting 4 in for x into the equation. So I can show out quite a few steps. You do need to be careful with your calculator for this. So you're doing -2 times 16 plus, what's 16 times 4? 64? Okay, so again, to show you every single step so you don't get confused. So now, just throw -32 plus 64 minus 33, and you're going to get -1. So again, what is that? You just found the y value of your vertex. So your vertex is at the point 4, -1. I'm going to jump over here and just graph this really quick. Okay, so 4, -1. That's the vertex. Okay? Remember, you also just found the axis of symmetry, that imaginary line. And what is that? X equals 4. The axis of symmetry, remember, is always, that's your next question, I call it AOS. It's always the x value of your vertex. And you always write it as an equation, because remember, it is a vertical line. So it's x equals whatever that x value is. Okay? Next question on your list that I asked you to comment on, I'm just, scrolling back to make sure I get everything. Hold on. Was does it have a max or a min? Okay, so looking at your equation, A is negative. So remember, when A is negative, that means it opens down. So it's going to look like that. And if you go back and watch my first video on this, when it opens down, you have a max. So for part C, does it have a max or a min? It has a max. And at what value is that at? It's always at your vertex, 4, -1. So notice I haven't really done anything with the graph yet. I'm just answering those questions. For part D, does it open up or down? Well, we just determined that it opens down because A is negative. It's -2. Part E, I labeled it as 1, 2, 3 on the homework, but I know you'll figure that out. Okay, the domain. So people were asking about this. They're confused about the domain. So for these types of equations, this whole unit that we're doing, quadratics, the domain is always all real numbers. So remember, you can either write all real numbers or you can do that little notation there. All right, F is the range. Okay, so let's do a quick review of that. So if it opens up, could open up or it could open down. Okay, so if it opens up, your range will be y is greater than or equal to whatever the y value of your vertex is. If it opens down, your range will be y is less than or equal to whatever the y value of your vertex is. And why is that? Well, look at it's opening up. This is the lowest y value on the graph. Everything is bigger than that. So y is greater than or equal to whatever that y value is. Why is this one always like this? This is the highest point. So that's the largest y value that you'll have, and everything else is below that. Okay, so for our range, remember, we just determined that it's opening down, and the vertex is at 4, -1. It's opening down, so my range is going to be y is less than or equal to, what's the y value of your vertex? -1. So that's your range. For part G, I think this is one of the easiest things of this whole process, the y-intercept. Remember, to find the y-intercept, you are always putting 0 in for x. But the shortcut of it is, if you watched my first video, it's basically your c value. Why? Because if I put 0 in here, that goes away. That goes away. So you're going to have 0 plus 0 minus 33. So when I put 0 in, I get negative 33. Now, the graph that we gave you for that worksheet does not have 0, negative 33 on it. So you're not going to graph it. You're just going to state it for me so I know you know how to find it. Okay, and then the last part, A, B, C, D, F, G, H, is the x-intercept. Okay, guys, so to find the x-intercept, this is up to you how you want to do it. You can use the discriminant to actually figure out if you're going to have an x-intercept or not. Some of you will be able to logically look at this and be like, okay, this is my max, this is my vertex. It's opening down. Is this going to cross the x-axis? No. Because the x-axis is up here, your vertex is here, and it's going down. So this one doesn't have any x-intercepts, but let me go through the steps to show you how you would figure this out. You can always do quadratic formula for these. You can also try to factor. Not every single one's going to factor. So let me walk you through in case you just don't see why it doesn't have an x-intercept. I'll show you mathematically why. So, using the quadratic formula, because remember, finding the x-intercept, that's what you did all last unit. That's what we were doing, taking square roots, completing the square, quadratic formula, and factoring. Okay, so I'm going to use quadratic formula. You could do completing the square if you love that too. So here we go, x equals negative b. So negative 16 plus or minus the square root of b squared minus 4ac all over 2a. All right, so let's simplify. I know I'm off. It's really hard holding the phone with one hand. All right, so let's simplify what's under the radical. You're going to do 16 squared. Again, I'm doing this all on my calculator. Minus 4 times negative 2 times negative 33. That's going to give me the square root of negative 8. So stop right there. Can you take the square root of a negative 8? No. So what does that mean? Does x have an answer in this case? No. This means no solution because of this negative 8. So what is our x-intercept for this one? You would say none. There aren't any. You're like, well, where does that leave me? I only have 1 point in this imaginary line, and the y-intercept is not on the graph. So here's what you would do in this case. And you might have also had to do this in number 1. You're going to make a quick table to the side and pick some easy numbers for yourself that are close to the vertex. So 4 is the x value here. I'm going to put 3 in. Okay, and you're going to go, you can do this right on your calculator, but you're going to put 3 into the equation to figure out what is the y value. So I'm just going to do this on my calculator. 9 times negative 2 plus 16 times 3 minus 33. I'm going to get negative 3. So that means I have the point 3, negative 3. Okay, this is where you can use the axis of symmetry to your advantage. The point 3, negative 3, that's only 1 unit away from the axis of symmetry. So if I were to reflect that over the axis of symmetry, that gives me the point 5, negative 3. Remember in my first video, I asked that you have 5 points on your graph. So in my little table here, it's not going to make sense to choose 5 because I already know that answer. I'm going to pick 2 as my next one. So again, I'm putting 2 into the equation, and then I'm just putting that into my calculator. But I'm writing this down so you can see what I'm doing. So you're doing negative 2 times 4 plus 16 times 2 minus 33. And when you do that out, you're going to get negative 9. This might be a stretch, but I don't know if it's on the graph I gave you, but 6, 7, 8, 9. So here's 2, negative 9. I'll do it anyway just to have that conversation. So 2, negative 9. How many spots away from that is it from the axis of symmetry? 1. I'm trying to look up here. Ready? You're 1, 2 spots away. 1, 2 away. So that means you go 2 on the other side. So 2, 2. That's going to bring you 1, 2. That's going to bring you to 6, negative 9. So 2, negative 9 reflects to 6, negative 9. 3, negative 3 reflects to 5, negative 3. So do you always have to do this table that I just did? No. You You only have to do the table when, you only have that vertex or you don't have enough of points. You can always pick values, but you want to do what you can with the y-intercept and the x-intercept. Keep the questions coming.